Well, hello, boys and girls. How are you? Yes, it is Mr. Broussard, and we are going to do another science lesson. We are going to do a lesson. Remember, I told you last time that we were going to find out two different types of waves. So now we know what a wave is. Now we know that light and sound and water travel in waves. We know how to measure waves. We know all of that. But today we are going to concentrate on recognizing, identifying, and being able to know the difference between two different types of waves. So let's look at the learning target so that we are clear about what we are learning today, okay? So I can explain the difference between longitudinal and transverse waves. Oops, there is a misspelling there. One moment, please. So let's do it one more time. I can explain the difference between longitudinal and transverse waves. So those are the two types of waves, okay? And we are going to be able to know how they are different. Even though they are both waves, they behave differently. And that is the target of our lesson today. First, before giving you much explanation, before telling you much about each type of wave, I want to show you a diagram, a drawing of each type of wave. And then I want you to write about the difference that you see. You might not know all the details and how they behave, but at least what you see. So let me show you these two types of waves, okay? So look at those two types of waves. So the top wave is transverse and the bottom one is longitudinal, okay? So you can pause the lesson right here as you look at those two types of waves, and I want you to write in your notebooks what is the difference between the two waves, okay? So pause and write the difference between the two type of waves, okay? So the transverse wave, I'm sure you wrote, it's kind of like it looks like the sea wave, right? Like the ocean waves. It goes up and down, and the blue arrows showed goes up and down, up and down. The longitudinal wave, longitudinal, I hope that you can say that word. I have a hard time saying it. So the longitudinal wave does not go up and down. It goes like it bunches up and then it spreads out and then it bunches up and it spreads out and it bunches up and it spreads out, right? They look very different. So I hope that you wrote all of that in your explanation of what you can see. Okay? You don't know exactly what is going on, but that's what you can see. Before we go on, I want to make sure that you remember two words from last lesson, okay? I want to make sure because that is very important to understand the two types of waves. So let's look at those two words. You remember amplitude? So amplitude is the height of a wave measured from midway between the highest and lowest point. So you can see it right there. That's the amplitude of a wave. Let's look at the other word, wavelength. And the wavelength of a wave is the distance between the same 2 points on a wave, such as crest to crest. You see there? From the top of the wave to the other top of the wave. That is the wave length. It is how long the wave is. So we could almost say that this is how long the wave is. And we can say that this is how tall the wave is. So I know it's not totally 100% correct, but we could say, just to remember, that amplitude is how tall it is, and the wavelength is how long it is, okay? Just as a quick reminder, remember a wave is a disturbance that transfers energy from one place to another place. It is important to know, to understand, that waves do not move matter. waves move energy. So when you see the water moving in the ocean, it is the energy that is moving through the water, okay? It's the energy moving through the water. So I think I might have said the water moving. So what is really happening is that the energy is moving through the water, okay? The sound energy is moving through the air or through another medium, okay? The light energy is moving, okay? So it's energy moving. So waves transfer energy from one place to another. Remember that, please. So I didn't mean to confuse you if I said that water was moving. What's moving is the energy in the water. Now, I want you to watch a video that's going to explain how longitudinal and transverse waves, I almost forgot the name, longitudinal and transverse waves work, okay? So let me show you the link to that video or so that you can click on that and watch that video after you pause the lesson, okay? And remember, you're looking specifically, that video has a lot of information on waves, but I want you to specifically pay attention to what a longitudinal wave is and what a transverse wave is, because that is our target today. The video is types of waves video, okay? So click on that, pause this lesson, and watch that video. Okay, just in case that you didn't take notes, okay, I'm gonna go a little bit through that video, and I want you to take some important notes of information that is extremely necessary for you to have to understand so that you can explain, okay, what waves are, what types of waves there are, and what are the characteristics of a wave, okay? So let me show you the first thing that I want you to write in your notebook. Please, in your notebooks, write a wave is energy. Very important that you write that down, okay? A wave is energy. Next thing is waves go through things, and those things are called mediums. It could be air, it could be wood, it could be metal, it could be water, but waves go through those things, okay? It moves the energy from one place to another through those mediums. This part right here is probably the most important part of the lesson because this is our target. So I want you to actually draw a transverse wave, which is the top one there, is wavy. And I want you to draw a longitudinal wave, which is kind of springy. Okay? So draw each one and label them. I don't think you need to write this down because I think you already have it. But just remember that the top of the wave is the crest. In Spanish, la cresta de un gallo. The red stuff that the rooster has on top is called la cresta. So the crest is the top. I'm sure that you already know this because we've mentioned it many times. But I want you to remember that light travels in waves, okay? Sound travels in waves. Energy moves through the water, okay? In the waves. Remember, I don't know, I want you to be clear. I want you to remember that the wave is the energy moving through the water, okay? And not all waves move at the same speed, okay? So remember, light is faster. Light energy moves way faster in those waves than sound energy. So not all energy travels at the same speed. There is a website that I want you to go to, okay? It's called Longitudinal and Transverse Waves, okay? It's Britannica Kids. So please click on that, and I want you to read that article. Let me show you what it looks like. So it looks like this, okay? It has a really good diagram, a really good drawing of a longitudinal wave and a transverse wave. And then it explains over here It gives you a lot of explanation about it, okay? So I want you to pause this lesson and go to that website and read it, please. So after going over vocabulary, after watching the video and reading this article, you should know the difference between a longitudinal wave and a transverse wave. You should even be able to do the drawing, okay? So one is wavy and one is springy, right? Longitudinal is long and transverse is springy, short, okay? Well, you have learned a lot about waves and how they behave and their characteristics. There is still a little bit more about waves that we have to do, but we're going to do that in a future lesson, okay? So I hope that you have a great rest of the day, and I will see you next time. And now you can, when you listen to music, you know that there are waves moving from one place to another. And when you suntan, you know that there are waves moving from one place to another, some faster than others. Bye-bye. See you later.